This is Geometry A, Unit 4, Lesson 6, Constructing Parallel and Perpendicular Lines. We're going to do a few geometric constructions. So get your compass ready. Compasses draw circular arcs. Get your straight edge ready. Straight edges draw straight lines. Straight edges do not have marks on them, so technically a ruler is not a straight edge. Though you can use a ruler, I recommend turning the ruler over so you're not looking at the markings on it. Okay, our first task is to construct a perpendicular through a point not on a line. Okay, and so here are the steps. We're going to start with a line. Can be facing any direction at all. I recommend using printer paper, unlined paper for these constructions because you don't want the lines to interfere. And let's mark point P here, a point that is not on line L. Okay, so my first step is to take my compass, and put the compass point on P. Open the compass far enough so that it reaches past the line. If I don't open it far enough, it won't intersect the line. I want it to intersect twice. So I'm going to draw a circular arc that crosses the line twice. I'm going to label the intersection points A and B. Intersections determine points. Okay, and then I'm going to take my compass, and I'm going to put my compass on point A, and I'm going to draw a circular arc from A, and then I'm going to put my compass on B and copy the same circular arc to B so that it intersects the last arc I drew. That intersection determines a point we'll call C. And now I'm going to draw a line through P and C. Okay? And this will create a line through point P that happens to be perpendicular to line L. Okay? So, to construct a perpendicular through a point not on a line, we start by drawing a circular arc from the point that crosses the line twice and label the intersection points A and B. Then we draw a circular arc from point A and copy that same circular arc to point B, mark where they intersect C, and draw a line through P and C, or line PC. Okay? And line PC is perpendicular to line L. All right, so that's perpendicular through a point not on a line. There's one construction. Let's do another. And the process changes a little bit when I want to do a perpendicular through a point on a line. Perpendicular through a point on a line. Okay, perpendicular through a point on a line. So we're going to start this time, the difference will be we're going to start with a line, and our point P is going to be on the line, anywhere on the line. Okay, and you're going to find it's very similar, okay, especially if I do it this way. The textbook had you make a mark, put your compass point at P and make a mark on both sides of P. You can also just do a nice big semicircle or a full circle if you like. Okay, but make a mark on both sides of P, and then intersections determine points. This is A, this is B. Okay, and I can now construct the perpendicular bisector of AB. So I'm going to put my compass point on A, and I'm going to draw a circular arc from A. Notice I had to make the arc bigger because it wouldn't reach otherwise. Put my compass point on B and copy the same arc as I did from A. New intersection point intersection determines a point. We'll label it C. and draw a line through P and C. Okay. Note, by the way, it is possible, it is not a bad step for me to actually draw the intersection both above and below the line. Okay, so I could have done this. I could have done a circular arc there and a circular arc here, and I could have marked both points, C and D, if you wanted. Okay, so, and again, it's not necessary for me to draw a full semicircle, but I just wanted you to see the similarity between this and the last construction that we did. All right, that's a perpendicular through a point on a line. So again, to remind you of the steps, step 1, I drew an arc from P that crosses the line twice and marked the intersections A and B. Make the compass bigger and make a circular arc from A. Copy that circular arc to B. Mark the point of intersection and draw a line PC. Okay, and technically, if that's a line, we should have arrows on the ends. Okay, so another construction here, one more construction, actually two more in this lesson. I'm going to construct a parallel through a point not on a line. Now, it would be meaningless to construct a parallel to a point on a line, because then that would simply make the same line all over again. Okay, a line parallel to a line on the point on the line would simply be drawing the line right on top of itself. So here's a point, we'll call it P. Okay, and there's actually several different constructions, but I will show you the one that was done in the lesson. Okay, in the lesson we drew a line through P such that it intersected line L. Okay, a line through P such that it intersected line L. We'll call this line T. Line T. Okay, and what we're going to do is we're going to copy this angle right here over to here. So we're going to do an angle copy. This is a construction you've done before in the last unit. So we're going to, intersection point, label it. I'm going to label this intersection point A. And I'm going to draw a circular arc at point A. Circular arc at point A. That crosses both sides of the angle. I'm going to copy that circular arc to point P. Okay. Intersections determine points, so this is point B, and this we'll call point C. This is point D. Now I'm going to take my compass and I'm going to measure the distance between B and C. Remember, to measure requires a compass. So I'm going to measure BC, and I'm going to copy that arc to D. Copy that arc to D. That intersection point we'll call E. E. That's the letter we're on. And we'll draw a line through P and E. A line through P and E. So P and E. Okay, and we'll call this line M. And by the converse of the corresponding angle theorem, which says if corresponding angles are congruent, lines are parallel, line M is parallel to line L. Okay, so let's outline those steps again. So we started by drawing a line that intersected P and L, labeled the point intersection point A. We then drew an arc at A, centered at A, that crossed both legs. And then we copied that arc to P. Then we measured the gap, BC. Then we copied that gap to D and found E. And then we drew a line, PE. So in that order. All right. There is one more construction I want to show you, and that is to construct a regular hexagon. It's really kind of a fun little construction. Not terribly hard. It's often something someone does when they just get their compass. Okay, so I'm going to put a point on the paper here. We'll call this the center. Okay, And we will draw a circle of any size centered at that point. Okay. Now I'm going to pick some point on the circle. Any point on the circle will do. And I'm going to draw another circle, or I'm going to measure a radius in both directions from there. Okay. And then I'm going to continue around, measuring off equal radiuses, equal radii. Okay. If you do it right, when you get all the way around the circle, you should end up right on top of where you started. Yep. So those match. Okay, and you will see there are 6 points equally spaced around the circle. You can now connect those points with line segments. Okay, and so here we go. And this will create what we call a regular hexagon. The word regular means equal angles, or all the angles are congruent, and equal sides, or all the sides are congruent. So sides are all congruent and the angles are all congruent. So this is a regular hexagon. Hexagon, hex, because it has 6. Six-sided polygon. Here we go. All right, there we go. All right, so that's it for now. Let me know if you need any help.